Good afternoon, Geometry Periods 3 and 4. How are you today? It's Thursday. It's the 28th of May. This is Maze coming at you from 308. Room looks a little different now. We've been told to take our rooms totally apart. So anyway, we're doing that. Okay, so in preparation for your semester test, I want to put the law of cosines, I want to put the law of sines, and I want to go over how to find the area of a regular polygon. Because this is kind of what's going to be on your test, and also you may have noticed that your CFCs also require the use of the law of cosines, the law of sines, and how to find the area of a regular polygon. So let's start off with the law of cosines, because that's, that's the funnest. So here we go. Okay, there are three versions of the law of cosines, three of them. Okay, now notice they look an awful lot like the Pythagorean theorem. They got the same a squared, b squared, c squared thing. Okay, but they have this piece on the end. And if we were in class, we would actually derive those three, but there's a lot of nice YouTube videos on how to do that. So there's your law of cosines. So what can we do with them? Well, if you're given a triangle and all you're given is the length of the sides, like this triangle here, okay, you have triangle ABC, and the side lengths are, notice that the big B, the little b is opposite angle B, 15, little c is opposite angle C, C is equal to 9, and little a is opposite angle A, and the side A is equal to 18. Well, I want to find the measure of angle B. That's the task. Find the measure of angle B. Well, to find the measure of angle B, I'm going to say that B squared is equal to A squared plus C squared minus 2AC cosine B. Okay? So basically, if you don't know the measure of the angle, you're going to solve that thing for cosine B. And you're going to wind up using your inverse cosine to actually find the measure of the angle. You're going to get a ratio, and then you're going to use the inverse to actually find the measure of the angle. So if you plug all these whiz-bang values in here, you will find that cosine B is equal to negative 180 over negative 324. Now that cleans up real nice to positive 5/9. Ta-da! All right, so you get your whiz-bang out, and you go second cosine, or if you have a dedicated inverse cosine key, you can use that. Anyway, 5/9, and you hit enter, and you'll find that the measure of angle B is equal to 56.25 degrees. Okay? Now you can use the law of sines to find the measure of the other two angles. And you only need to find one angle, right? Because you'll just do the 180 trick after that. All right, now the law of sines is very useful if you know the measure of an angle and its opposite side. In this case, we have the measure of angle A and the length of side A, and then you need a measure of another angle or the length of another side. Okay, and there's your basic law of sines. Now I put the numbers that meets our example right here, but basically it's sine A over A is equal to sine B over B is equal to sine C over C. So I got my whiz-bang out and I said sine 70.9397 divided by 12 is equal to sine 50, which is 0.7660 divided by B. Do a little algebra, and lo and behold, B is equal to 9.78. Okay? So you could find the length of the other side using the 60-degree angle, okay? But that's how you use the law of sines. Okay, now let's come back and use some of those right triangle trig ratios, okay? I'm going to give to you an octagon. This time it's going to have a radius of 12. And what does radius mean? It means that if the octagon was set inside of a circle, that the vertices all on the circle, the radius of that circle would be 12. Okay? I forgot. I'm getting sloppy about that. I got to get back on that. Okay, so I got my 90 degrees in there now. Okay, so I take my octagon, or whatever n-gon this is. I mean, it could be 12, 18, 20, 30 sides, whatever. Okay, and take 360 and divide it by the number of sides. That's going to give you the measure of that angle that goes from a vertice to the center to an adjacent vertice. Okay, so I took that little piece of triangle and I put it out here. Now notice I've got 22 and I have a 12 up there. Well, what's half of 45? That would be 22.5, okay? Now that little dotted line I drew, that's the apothem, okay? So then I drew half of that triangle, okay? Now notice that that was the side. Now it's a half a side, okay? Now I can use my right triangle trig ratios to find the length of the apothem and to find the length of half the side, okay? So, which trig ratios would you like to use? Well, obviously, if you know the hypotenuse and you need the adjacent, cosine comes to mind. And if you know the hypotenuse and you need the opposite side, sine comes to mind. Okay? All right, so anyway, you can crank those sine ratios in there, do a little algebra right there, and then the apothem will equal 12 times cosine 22.5, and the side will equal 12 times sine 22.5 is equal to half the side. Please, please, please. You could multiply both sides by 2 right now and say that 24 sine 22.5 is equal to the length of the side. And then, of course, the area is equal to 1/2 the apothem times the perimeter, or you can think of perimeter as the number of sides times the length of the side, okay? That's how you would find the area of a regular pentagon. In this case, it's an octagon. Now, if that was a pentagonal cone, or I'm sorry, a pentagonal pyramid, then you would say, all right, the volume of that would be the area of the base times the height divided by 3, okay? Now, to find the surface area of that, you need to find the face, and that's where that slant height comes into play. And the base of that triangle is going to be the apothem, and then the height, and then the slant height, and then you'll draw another triangle with that and the base, and you'll find the area of that. But anyway, I didn't do that quite yet. So I wanted to highlight those 3 things today. That's how you find the area of a regular polygon. This is where your right triangle trig ratios come in. If you have a triangle that is not a right triangle, then you can use the law of cosines or the law of sines depending on what information you have, okay? If you don't have the measure of an angle and you've got all 3 sides, law of cosines is kind of what you're stuck with, okay? Or if you have 2 sides and an included angle, the law of cosines is what you're stuck with, okay? The law of sines works real well if you have the measure of an angle, the length of the opposite side, and 1 more piece, either the measure of another angle or the length of another side. And then it's just a simple ratio, okay? All right, that's kind of what I got for you today. I would like to remind you that today is Thursday. Tomorrow is Friday. It's the 29th. It's the last day that I would like to accept coursework. After that, man, it's that semester test. I posted the semester test out there for you. It's not bad. Most of it's pretty simple. There are a few of them that you're going to have to think. I did lay some traps for you. There are some pitfalls out there, and I know some of you will step blindly into them and think, man, this is easy. And no. Anyway, please know your stuff, okay? It's designed to differentiate those that actually know what they're doing from those that really don't have a clue. And remember, if you are currently passing with a 70-ish or better, you're golden. If you don't have that kind of a grade, you have to do more work. If you opt not to do the semester test and you have less than that, you are in a lot of trouble, okay? You'll be sporting the super one-legged A, and that ain't good. All right? If you have questions, please feel free to ask them. Most of you, I'm getting pretty good at responses now. You send them in, I get an answer back to you pretty quick. So let's keep that up and keep those assignments rolling. So anyway, we're almost out of time. That's all I got, man. May's out.